So we're going to continue with the last section of Chapter 5 on the single responsibility principle. Um, so far we've looked at a big, long method that we broke up into smaller methods. So we refactor that for clarity. And then we refactored that using interfaces here for abstraction so that it would be easier to work with. So we did that last couple weeks. Now we're going to talk about this kind of pattern or method in general. So we're going to go down here to this section where we're going to talk about the decorator pattern and how that works. So the decorator pattern is kind of a generic version of this. So let me stop for a sec and show you the code. So if you remember in our code, we had a set of interfaces to our different parts we defined. And then we also had our code that was broken up in a number of different classes. And our main program went through this process of creating some objects and then passing them to the trade processor to do things. So, and we kind of build objects out of other objects. So for example, we created a trade mapper and a simple trade validator. We pass those both to the trade parser. And then again, we'd pass the trade parser and the storage and the data provider to the trade processor. So we kind of built things up of other components as we did. And that's kind of what the decorator pattern does in some ways. So we'll look at that. And so in all of these areas, we often have an object inside another object. So we'll have one object wrapped around other objects. So that's kind of what this, oh, and I'm jumping one back. I forgot to mention interfaces. Now in all of these, we might have a simple trade mapper, but that is going to implement an interface. So all of these objects will be defined through their interface. And then so when we pass these to like trade processor, it's going to expect things defined through their interface. So again, so we have some concrete component that does something, and it defines an interface. And then we're going to add another decoration around it that's going to include this component that does something, but implement the same interface. Now, I don't think this diagram is that great. So maybe we'll look at a different diagram that tries to show this. Okay, let's look at this diagram. So this shows a main class and just a concrete component without a decorator class yet. And we just defined an interface, and this concrete component is going to use that, implement that interface, and this main class is going to use, create or use this object through this interface. So the interface kind of is almost like a plug that you can look at, that if this object creates or implements an interface, then this can use that interface, and this main class needs something that uses that interface, and we can plug these things together through this interface, this set of methods that are the interface defines, and then we can use these. But we're going to move this. We're going to basically have this decorator class, and we're going to add this decorator class in here. And we're going to add this decorator class and break this link and have the main class use the decorator class. It's going to use the same interface. So the decorator class is going to implement the same interface, but now we can kind of plug it in. This lucid chart's not the best chart for doing this. I can plug it into this interface, and then the decorator class will create an object. We'll create one of these concrete components and use again the same interface to implement it. So basically, the decorator class it's going to include a concrete component and add some features to it, but while maintaining the interface being the same interface. So the main class won't see much difference because it's still using it to the main interface. That's kind of what we're getting at here. And again, I don't love this diagram. It's okay, but it's just not, it's hard to show that. But here's an example of the code, which might be more useful. So we defined some interface. We said, and it just has one thing, a method that does something. And the concrete component is going to implement that interface. It's going to do something here. And then here's our main class set up here. I'm sorry, no, this is our decorator component here. And so it is going to include, it has a variable here that's going to be one of these concrete components. And then when we construct it, we pass in this concrete component in here, and it will remember it using this variable. And so then when it's going to do something, it implements the same interface. When it does something, it might do something else here, but the main thing it does is it calls the decorator components do something method. It calls the method up here. Maybe we'll look at this in code to see it. So I've taken that same code and just put it in Visual Studio here. So let's look at that. So again, we've got this interface, which is just something. It's called an I component, just a generic interface. In our example, we'll look at examples that are more specific, but this is just want to be more general here. So it just has an interface, and it defines one or more methods. And then we have a concrete component that that implements that interface. So it has to have a something method. And right now it says it just writes out we're doing something. So I actually have it doing something in the book. They have that blank. But in order to see this work, I thought we should actually print something out. Now, you could have the program create one of these components and use that. So here we have, we're creating just a concrete component, naming a component, and we're going component.do something. So we can run this, and it's just going to say, print out, we're doing something. So all this says is we're doing something, and then press any key to continue. So it just runs this, creates a concrete component and prints it out. So that's what we were basically looking at here, where the main class has created a concrete component initially. Now we're going to put this decorator in the middle of it. So let's look at how that might be done. So we declare a decorator class, and it implements that same interface. And again, we're going to keep a copy of a decorator component inside. So we're going to have a constructor here that's going to include one of our concrete components here, something we're going to decorate. And we're going to store that in this local variable. So then when we call do something, it's going to call decorators do something. And again, it may do something else. So we also define this do something else that prints this out. So now in our main program, rather than just creating a new concrete component, we could create a new, let's do this right, new decorator component, and inside of that pass in a new concrete component. Let me get my parentheses matching up here. Because the decorator component needs as its constructor a concrete component. So again, we'll create one of these and put it in here, and then we'll call do something here. Now we can run this also, and now it says we're doing something else, and then we're doing something. So it's calling the original do something method, but also adding some features to this. And that's what decorator components do, is add some features onto an existing method. Now, what's important is that we don't have to, although we have to modify the constructor up here, the rest of the code shouldn't have to modify. In this case, it's just one little line. But in general, this might be a big, long, complicated procedure, and all we have to do is change the constructors here, and then everything relies on this interface. And so since the decorator implements the same interface as concrete components, none of the code should have to change other than constructor. Now in our to see how this matches the code we looked at before, we can declare another component here. The deck component, and I'm just going to move this in here. I'm going to call it a concrete component. So I'm just going to declare this in a separate line and then put it up here. So this is the same thing. I had this new right in here, but this matches. If you remember our code from the currency trader, we created a number of objects here, instantiate them, and then we pass those objects to another object to basically add features or decorations around it. So that's why they introduced that this example in this chapter is this decorator idea. Okay, let's go back to the textbook. So again, this lays this out and talks about that component. And we'll look at some other examples of this later on. We'll look at specific examples. Now this is a specialization, but a little different one. This is called a composite pattern. So similar here, we have an interface where we're going to do something. And we have a concrete component. This is called a node or leaf here. And then we have another component that's going to include multiple ones of these. The kind of idea here is that here, the main class, we have a decorator that includes one of these concrete components. What if we wanted to include more than one of these components? So, for example, here we have this decorator component, and we included one of these objects. What if we wanted two or different objects that both did the same interface, or three? We could add another one to this constructor, and maybe even a third. In fact, in our example in the currency trader, we had three different interfaces, add three different objects here. But if you want to make this more generic, you'll use this composite pattern. So let's look at that. So that's this kind of setup, and then inside our composite thing, we'll go through a for loop and look and do something for each child of this pattern. And this lays out the code here. I'm going to open that code up in Visual Studio so we can look at it there also. So here's our interface. I component is just called, and it's called do something. We have a leaf node, which just does something, leaf 1. Now we're going to have a couple different kinds of leaf nodes. So we have a second type of leaf node that prints something else out, and a third type of leaf node. But all of them implement the same interface. So in that way, even though they're all different, we can treat them all the same because they all implement this one interface. So let's look at our main program. So again, we could create just we could create a leaf, save it as a component, and it's an I component. We define it through this interface. So we can define that, and then we can say component A do something or something to do that. So that's just a really simple version of this. But now we're going to group a bunch of these leaves together in a composite component. So we're going to create a new composite component, and then we're going to add leaves to it. Now, before we looked at, when we created a constructor, putting the leaves in here, but we don't know how many there are going to be. There might be enough. So what we're going to do is define an add component method. So once we create one of these objects, we can add new objects to it. And then finally, when we have this whole composite object built, we're going to save that to a component object, which is going to, again, implement the same interface. So once we do this, whether or not we've created it this way or this more complicated way, in the code, we can just say component A something, component B something, and it's nice and simple. This code's very simple, even though all the complexity was set up in the constructor, and all the code is the same. And if we run this, it'll just print off. So this is the first print off. This is an elm leaf, and then this is the next one. We have a leaf 1, a leaf 2, and a leaf 3 that are available. In fact, we can actually build these. We can create more components and do things to it in different ways. So we could actually define another composite object and add it to this object and build these up. Because right now in this composite object, we're adding a leaf object, but we could add another object. In fact, like we could add one of these objects to this. We could just say composite object dot add component and add this thing to it. Anything that implements this interface can be added to this composite object, and so we can actually add another composite object to this. Okay, let's jump back to the text. So this walks through that same code we just looked at, and again, this is the actual code we looked at. We have multiple leaf types. And then again, I said we can have the client, the main program, and it creates a composite object. And in that, you could have 3 leaves, but you could also have a leaf, another composite object, and another leaf. And in fact, that composite object could have a leaf and a couple leaves, or we could create this whole complicated structure of objects that are all these will implement this interface, and we can kind of create. So it could be like a folder structure or anything like that we want. An inventory structure where we have backpacks that contain other objects or things like that. So, all right, so that's the composite version, and again, it's just a kind of a specific version of the decorator pattern. We have multiple ones. Okay, now we're going to look at a couple other examples, and some of these we're just going to skip over. So they have a predicate decorator. I'm not going to go much into that and how that's set up. Just another example of a decorator pattern. I'm just going to pick and choose a couple of these to look at. They have a branching decorator, and this actually has two components that you add. You create it with two components, and then you have some tests, and you choose to use one component or another component inside of it. So you actually build up with two. So it's another example on the way to building to a composite one, which has as many as you want. Lazy decorators. I'm not going to get too much into lazy stuff. Lazy usually means that we're often like we may not create or instantiate objects until we need to, or things like that. So there's different ways of setting up this lazy instantiation stuff. But again, I'm not going to go over that. There's logging things where we can add logging information around. So we might have a class, but we want to log its activity, so we can wrap it up in a log area. And again, we won't do that too much. Profiling, where we can time an object, how long an object takes, and add some timing features to it. So this is just different kind of features or decorations we can add to different objects that are used more frequently than others. Now we're going to look at this asynchronous decorator, and the assignment's going to be focused on this. And so we'll look at this oftentimes when we're doing a Windows interface or something like that. Click on a button and you'll do something. If that takes a second or so, it'll freeze up the interface because it's all running in one task. So there's an option where you can run some of your methods or some of your functions in another task, create a separate task, and that's called asynchronous. So now, in a normal model, everything goes line by line through the code, line by line. And we might run off and do a method, but then while we're doing that, we're waiting, and then when we're done with the method, we come back and we continue on with our main program, and then we may go off there again. But with asynchronous tasks, we can tell it to do a method, and then we can keep going with the rest of it. So we'll look at that. There's this task.run command, which will take a method in an object and run it in another task. And we'll look at this more when we do the assignment and the prep for the assignment. Now one place that this works best is what's called the fire and forget methods, where we're going to go do a method and we don't care, we don't need any results from it or when it's done. So we'll do it with our database part where we'll tell it to go out and write the information to the database, and then we don't need information back from that necessarily. But there are problems, and we'll look at those where if you want to go out, do information, bring information back, it makes this a little more complicated. So again, we'll look at this in the assignment. There's a strategy pattern that uses this switch statement. So again, you can, rather than having a switch statement that will jump between different objects here, we could just have, we can create object where we add, this is like the composite pattern. We add different objects to our strategy pattern, and then we can then use an index into those, like an array index. But this is a dictionary, so this is actually can be a word or a name or something like that, or an object. And so we can use that to then call the right object in this class. But again, we're not going to go too much into this detail either, but these are different ways where you can use this composite pattern in different ways. So Like I say, an assignment will focus on one of these, and that'll be the asynchronous decorator pattern.